We have seen that during the 17th century, a huge transformation happened in the way people investigated nature and the universe. Tycho Brahe used his powerful instruments to measure planetary orbits with unprecedented precision. Galileo used an instrument, the telescope, to look at the heavens as no one had before. He also devised experiments, ways of testing a scientific hypothesis, by gathering data and searching for mathematical patterns that could reveal a law of nature. Kepler used Tycho's data to figure out that the orbits of the planets are elliptical and not circular. Newton used all of the above to come up with a beautiful and all-encompassing theory of gravity that showed that the same force that makes an apple fall on Earth is responsible for making the moon orbit the Earth and all the planets orbit the sun. All this was possible because of essentially two ideas. First, that we can perform experiments to test what is called a scientific hypothesis. These experiments can be repeated by anyone who has the required equipment. If the same exact conditions are duplicated, then the results of the experiments should be the same, at least within the precision of the measurements. The second central idea is that tools are essential. They provide a sort of amplification of the five senses. Telescopes, for example, let us see much, much farther than what we can see with the naked eye. Microscopes let us see things which are way too small to see with the naked eye. So tools can reveal some of the hidden aspects of reality, amplifying the way we understand the world. I like to call them reality amplifiers. Tools to gather data and experiments to test a hypothesis are the lifeblood of modern science. We measure what we see of the world the best way we can, and we set up experiments to investigate behaviors we don't quite understand. Results of these experiments should be repeatable. This methodical process is known as the scientific method. However, we can see that the very nature of the scientific method exposes its limits. First, tools have limitations. We can't see everything there is to see. A telescope can only see so far and with some precision. The same with any measuring equipment. What falls out of the instrument's reach remains also out of reach for us. We can only see a fraction of what's out there. And two, experiments have limitations. They are designed to measure specific phenomena and effects and can only catch what falls within their reach. Sort of like a fishing net. Small fish can escape if they're smaller than the size of the holes. This means that many phenomena and effects remain outside what we can test. A part of nature remains out of reach, like the fish that go through the net. In science, we can make a finer net, but we can't ever make a net that catches everything. To illustrate the scientific method, let's perform an experiment with a pendulum. First, note that the pendulum that we have in the lab is representing many other systems that have pendular motion. Kids in swings, leaves and trees oscillating in the wind, chandeliers, any motion really that oscillates back and forth. This is a really important point. Experiments model natural phenomena, but they are not the phenomena they model. A good experiment is one that captures the essence of the phenomenon we want to examine without being bogged down by unnecessary details.